Hello, today I will prove arithmetic mean and geometric mean inequality, sometimes known as AMGM. In this inequality, we are given n positive numbers, a1 all the way up to an, and we know that their average is always greater or equal to their geometric mean. To prove this, we will use induction, and for two numbers, if we are given numbers a plus b over 2, we need to show that this number will be always greater or equal to square root ab. If we take both sides in square, we get a plus b square must be greater than 4 times ab. So this is a square plus 2 times ab plus b square minus 4ab must be greater or equal to 0 for every a and b. Clearly this equals a minus b squared, and because we know that a and b are positive real numbers, this number into square will be always greater or equal to 0. So we have proved for n equals 0. And for the induction, we will prove that, let's assume that we know this for some number k, and for k, from k we will go to 2k. So for every k numbers, a1, a2 up to ak, we know that their average is more than their geometric mean, a1 times a2 times all the way up to ak. And now let's discuss another k numbers, ak plus 1, ak plus 2, all the way up to a to k over k. This number will be also greater than a1, ak plus 1 times ak plus 2 times all the way up to a to k. And if we take all these numbers, so from here we can conclude that sum of ak's, I equals 1 to k, ai, this is greater or equal to k times k root from a1 times all the way up to ak. And from here we can conclude that this sum from I equals k plus 1 to 2 times k will be greater or equal k times k root from ak plus 1 times ak plus 2 times all the way up to a to k. Now if we take the sum of these left hand side and right hand side, what will we get? We get that numbers sum of I equals from 1 to 2k ai, this is greater than k times k root from a1 times a2 times ak plus k times k root from ak plus 1 times all the way up to a to k. But now we can write also AMGM for these two numbers. If we take this k out of brackets, we are given two numbers, k root from the first one and k root from the second one. Now if we apply AMGM once again, we get that this is greater or equal to 2 times k times 2k root from numbers from a1 all the way up to a to k. So this was all we wanted to show. So from point of k, we have moved to the point of 2 times k. And to finish our induction, we need to show how can we get back from some point n to n minus 1. And how can this be applied to our inequality? Because we know that a1 plus a2 plus all the way up to an over n, this is greater or equal nth root from a1 times a2 times all the way up to an. Then instead of an we can write any number. So instead of n we need to write n minus root from a1 times a2 times an minus 1, sorry. Now look at what will we get. In this case, we will get that a1 plus a2 plus all the way up to an minus 1 plus n minus root n minus root from a1 times a2 times an minus 1 over n. This number is greater or equal nth root from a1 times a2 times an minus 1. This multiplied by the nth root from this number, n minus 1 root from this number, a1 times a2 times all the way up to an minus 1. Clearly this number equals n minus 1 root from a1 times a2 times all the way up to an minus 1. Now if we multiply both sides by n, we get that a1 plus a2 up to all the way up to an minus 1 plus n minus 1 root from a1 times a2 times all the way up to an minus 1. This must be greater or equal to n times n minus 1 root from a1 times a2 times an minus 1. Now we can cancel out these terms, and instead of n we need to write here n minus 1. Clearly if we divide both sides by n minus 1, we will see that average of these first n minus 1 numbers will be greater or equal to their geometric mean. So we have proved for every number that if we take n minus 1, any positive n minus 1 numbers, we can also prove that their average will be, arithmetic mean will be always greater or equal to their geometric mean. This technique is very useful in most of the inequality problems. I will link in the description one of the IMO shortlist problem which can be solved by using this induction technique very easily, and I will also link AMC, DCR AMC problem